Hello everyone, in this video we're going to talk about inter-process communication and synchronization. So what is an inter-process communication? Well, inter-process communication is an ability of one program to communicate with another program. The process can be on the same computer or different computers connected through a network. Okay, so let's talk about inter-process communication in a distributed system. Now, what is a distributed system? Well, a distributed system is a collection of computers or nodes that are connected to each other through a network. And we will discuss about the distributed system in detail later on. However, for now, let's focus on the inter-process communication in a distributed system environment. So processes can communicate in two ways. First is the shared memory, and second is message passing method. Let's talk about shared memory. Okay, so let's talk about the shared memory model first, which is on the left hand side. So in shared memory model, a region of memory is established which is shared by the cooperating processes. The processes can then exchange information by reading and writing data to the shared memory region. So in this case, let's say a process A wants to communicate with the process B. So what's going to do is it's going to write the information onto the shared memory. And then process B is going to read from the shared memory. Okay, and that's how they communicate with each other. That's how these two processes communicate with each other. So that's your shared memory model. And in the message passing model, process A is going to generate a message. That message is going to get passed to the kernel. And then the kernel is going to pass the message, that particular message, to the process B. So this message from process A goes to the kernel, and the same message goes to the process B. So that's how the inter-process communication takes place between the processes in these two models. Hello everyone. In this video, we're going to talk about inter-process synchronization. So what is synchronization? Well, synchronization involves the orderly sharing of system resources by the process. It ensures mutual exclusion and event ordering. So we will discuss what a mutual exclusion is in the upcoming videos. However, just to give you a brief idea is that the mutual exclusion says that one resource should be held by one process at a time. So one resource cannot be shared by two different resources at the same time. So one resource should be given to one process at a time. Once that particular process finishes executing, then is going to be given to other processes. That's your mutual exclusion. So synchronization basically controls this, all of these ordering of the events or all of these processes, as well as the mutual exclusion. So it ensures, it governs that. Okay. So we need to ensure that the processes are synchronized. So the first thing we have is the critical section. Now, what is a critical section? Well, a critical section is a part of a program in which it is necessary to have exclusive access to the shared data, which means only one process should be executed at a time, and that shared data should be given to that process. Now, there are certain problems that operating systems face in allowing and disallowing the processes from entering this critical section. And we are going to look at those problems in a moment. So just take a look at this one. Let's say we have a condition do while the condition is true. You have an entry section where the process enters the critical section. It gets executed in the critical section where it's supposed to have an exclusive access to the shared data, and then it exits the critical section. So any solution, so to solve the problem, as we discussed, operating systems face this difficulty in managing the processes from entering the critical section, like allowing and disallowing. So to solve this problem, it needs to satisfy three different requirements. First is mutex, mutual exclusion. So what is that? Well, mutual exclusion, as I've already explained, it means that one resource should only be used by one process at a time. So for example, two processes should not be attempting to update the same bank account. So while one process is updating your bank account in the system, another process should wait on that, let it finish updating, and if it needs to do anything, it can do after that, after the first process is finished its execution. Now, a mutual exclusion can be achieved by a system of locks. So what is a lock? Well, lock is a software mechanism that is implemented in user mode, so no support is required from the operating system. So we'll discuss about the logs in depth later on, but just thought of giving you a basic information about the logs. So a mutual exclusion log is also called mutex. Second requirement for solving the critical section problem is progress. What is a progress? It means that if no process is executing in the critical section and other processes are waiting outside the critical section, then only those processes that are not executing in their remainder section can participate in deciding which will enter the critical section next, and the selection cannot be postponed indefinitely. So that's your progress. That's your second requirement. The third requirement is bounded waiting. A bound must exist on the number of times that the other processes are allowed to enter their critical section. So basically there needs to be a bound on how many times that other processes are allowed to enter the critical section. After a process has made a request to enter the critical section and before that request is granted, there needs to exist some kind of a bound on the number of times. So that's your third requirement. We will now discuss how to solve the critical problem using different algorithms. There are several algorithms that solves the critical section problem. One is Decker's solution for mutual exclusion, and second is Bakery's algorithm. So we'll discuss these in the next video. Hello everyone. In this video, we are going to talk about Bakery's algorithm. So what is a Bakery algorithm? Well, Lampert proposed this algorithm, which is a software solution to solve the end process mutual exclusion problem. So in the previous video, we discussed about there is a critical section problem that we need to solve, and there are different ways of solving it. There are different algorithms to solve it, one of which is Bakery's algorithm. Okay. So Bakery's algorithm is a software solution to solve the end processes mutual exclusion problem. What is the mutual exclusion? Well, mutual exclusion means only one resource should be allotted to one process at a time. So no two processes can have the same resource. If the second process needs that particular resource, it needs to wait until the first process finishes the execution, and then when it voluntarily releases that particular resource, then is going to give into the second process. So one resource should be allotted to one process at a time. That's the mutual exclusion rule. Okay. Okay, so it solves the problem of the fairest, which is first in, first out. Now, why is it called Bakery's algorithm? Let me explain that to you. So when a customer goes to a bakery, the bakery manages them on a basis of tokens, right? So when you enter the bakery, you are given a token number, and then the next person enters, he gets a token number as well. There's a global counter on which the token number is flashed, which means it shows that which is the current customer who is being served. Once that particular customer is served, the next token number gets displayed and the next customer gets served. So that is how the customers are managed in a bakery, right? So similarly, in the Bakery's algorithm by Lampert, processes are treated as these customers. Okay, so each process gets a token number, and the process with the lowest token number gets to enter the critical section first. So let me show you the code snippet for how this works. So you can see it says do while it's true, and then you have choosing, you have these. So let me explain these to you one by one. So let's say there's a process PI that needs to enter the critical section. Here's your critical section, right? What it's going to do is it's going to set the choosing I value equals to true. So by setting the choosing I equals true, it lets the other programs know, or the other processes know, that it's choosing a token number. That's why it sets it to true. Then it chooses the token number larger than the token number assigned to other processes. So this max is going to give the token number that's been assigned to the previous one. So you add 1 to that. So even in bakeries, you know that if the current token number is 10, then the next person or next customer gets the token number as 10 plus 1, which is 11. So that is why it chooses the token number which is larger than the previous token number. Okay. So once it chooses that, then it sets the choosing I to false, which means it's letting the other processes know that it has finished choosing the token. Then it enters the loop to evaluate the status of other processes. And here it's going to wait until the process Pj finishes choosing its token number. Pj then waits until all the processes with smaller token number have been served, and once that is done, it's going to enter the critical section, and after it has finished its execution, it's going to set the ni to 0 and exit the critical section. Now the number scheme always generate the numbers in increasing order of enumeration, for example 1, 2, 4 times 3, 4 and 5. All right, so that basically is the bakery's algorithm. I hope it's clear to you. Thank you.